Welcome to the class on Max. We are going to discuss about probability. Okay, we have seen an introduction to probability in our concept building classes. So we will have a quick introduction and we will proceed ahead. Okay, so what is probability? Probability is mainly we are going to discuss about chances. Okay, we are mainly going to discuss about chances. So probability mainly derived from set theory. We have seen how it evolved in the concept building classes. We'll have a very quick brush up of that. What your set theory says and what your probability evolving out of it. What is a set theory saying? We have something called epsilon. It's called the universal set. Okay. And then we have a set AB. It looks something like this. This is epsilon. This is my set A. This is the set B. This part is called A intersection B. Correct? If I do like this thing becomes, the shaded region becomes A union B. A intersection B is the common one. Correct? Then what else we can say? This is the universal set epsilon, and I say this is my set A. This is nothing but A complement, and A intersection A complement will be what? Null set. That is, A and A complement are always disjoint. Correct? And A union A complement will give the epsilon, the universal set. Okay. Then probability. What probability we are going to have? We are going to conduct an experiment. Okay. The moment experiment is conducted, we have a set called S, which contains all possible outcomes. And I have a set called E, which contains desired outcomes. Okay. So what I can say, E will be definitely a subset of S. Why? Because S contains all outcomes. So whether E can contain all of S or E can contain less than S, but E can never exceed S. Please remember this, because S contains all the possible outcomes. Clear? E is the desired outcome. Okay. Now what I can say, E complement is the, what is, if E is the desired outcome, what will be the set E complement? All outcomes other than desired outcomes. Correct? So E complement will also be a subset of S, and E union E complement will give me S, and E intersection E complement will be null set. That is, E and E complement are disjoint. E is okay, and probability of an event P of E is defined as N of E by N of S. That is, number of desired outcomes by total number of outcomes. Okay. Then what will be P of E complement? P of E complement is nothing but N of E complement by N of S. Okay. Now if I do P of E complement plus P of E, what will I get? It is nothing but N of E complement by N of S plus N of E divided by N of S. This is nothing but N of E complement plus N of E divided by N of S. Now what are E and E complement? E and E complement are disjoint sets, correct? Okay, now let me ask you one question. What will be n of E union E complement? N of E union E complement will be n of E plus n of E complement plus n of E intersection E complement, correct? But E intersection E complement is null set, right? So n of E complement will be E intersection E complement will be 0. So n of E union E, what is E union E complement? This is sample space S. So n of S, let me write this clearly again. E union E complement is nothing but sample space itself, because E and E complement are disjoint, correct? And E complement contains everything except E. So E and E complement together mixed will give me the sample space S. So n of S will not be nothing but n of E plus n of E complement. Let me call this equation 2 and let me call this as equation 1. So use 2 in 1. Use 2 in 1. What we will get? N of E complement plus n of E is nothing but n of S. So P of E plus P of E complement is nothing but n of S by n of S. That is nothing but 1. This also we already proved. This is a very important result. Okay, fine. Now, so what we saw just now, P of E plus P of E complement is 1, correct? Now what do you mean by P of E? Probability that event E will occur. Now what is probability of E complement? Probability that E complement, event called E complement, will occur. Or in other words, if I have to write this, what it means? What it means? Probability that event E will not occur. Please remember this. If you want, we can realize the meaning of this in a one quick problem. Okay, let me say, throw of a dice. From throw of a dice, what is the probability that we get a multiple of 3? What are the possible outcomes? S will contain all possible outcomes. So 1, 2, 3, 4, 5, 6. E is what? E is what? Multiple of 3. The favorable outcomes, right? So we should get a multiple of 3. So 3, 6 is a multiple of 3. So what is probability of E? Nothing but n of E divided by n of S is nothing but 2 divided by 6. That is 2 elements are here. Number of elements is 1, 2, 3, 4, 5, 6. So totally 6 elements are there. So we will get just 1 divided by 3. Now what will be probability of? What will be what will be the set E complement? E complement is nothing but, how will you take complement? See, remember the set theory. This is set A. This is universal set. What is A complement? This is A complement. That is everything in the sample universal set except the elements contained in set A. This is called A complement. Similarly, what will be E complement? I have the sample space S. Everything except what is present in E. From the sample space I have to write. So it will contain 1, 2, 4, 5. So what will be probability of E complement? Probability of E complement is nothing but what? 4 divided by 6, that is nothing but 2 by 3. We can see that probability of E plus probability of E complement is what? 1 by 3 plus 2 by 3, that is nothing but 1. That is what we got here, right? This is what we got here, correct? It is an illustration of what we got now. This one is an illustration of what we got. So probability of E plus probability of E complement is 1, or probability of E complement is nothing but 1 minus probability of E. This is very important. Okay. Then now, having solved this as one quick introduction, we will go little bit further now. So we now saw about these basic things. Now let us understand principle of counting. This is very important. Principle of counting. This is very useful in finding n of E and n of S. This is what we will be using for finding n of E and n of S. So what do you mean by principle of counting? I can have two, there are two important concepts. That is, one is called combination. The other one is called permutation. Please refer, I am going bit fast here. Please refer to the lecture on basics of probability for more information on this. Okay. I am going to give a quick refreshing here so that we can solve more problems now. What do you mean by a combination? Combination is nothing but, we write it as NCR. It is nothing but n into n minus 1, so on. We have to write R terms. So what will be the last term? It will be n minus R plus 1 divided by R factorial. And also there is one more important result called NCR is nothing but NC n minus R. Okay. And what do you mean by NCR? What it means? The meaning is very important. Meaning, what is the meaning of NCR is, from a set containing n elements, how many groupings of R elements are possible. This is what NCR is going to tell you. From a set containing n elements, how many groupings of R elements are possible. That is what NCR is going to say. And permutation is nothing but NPR. This is nothing but n into n minus 1 into n minus 2, so on till n minus R plus 1. This is what is NPR. Okay, so what is the meaning of NPR is, we will see all these things by help of problem, don't worry. Meaning of NPR is, what is the meaning of NPR? From a set containing n elements, how many ordering, this is very important here. Here it is grouping, it is ordering of R elements are possible. This is what your NPR means. Okay, fine. Let us solve more problems on. Okay, fine. Now let us take one example. Let us take one example. Say that I have 4 cards named A, B, C, D. Okay, how many groupings of 3 cards are possible? How many orderings of 3 cards are possible? This is what we have to understand. Okay, now let us solve this from the scratch, thereby understand what do you mean by permutation and combination. I have 4 cards named A, B, C, D. Okay. Now I am going to see how many groupings are possible. Here I will see how many orderings are possible. Okay. Grouping means order is not important. Order is not considered. Okay, we will see the meaning of it. Order is not considered means ABC is same as BCA is same as ACB, like that. So I don't bother whether A is in the first place or A is in the third place or B is in the first place. So ABC means it covers all these things. It can be ABC, BCA, ACB, CAB, all those things. I don't consider where A is placed, where B is placed, where C is placed among these three. That is what is called groupings. Okay? Okay, fine. Now, let us see how many groupings are possible. Now, let me take the first card as A, second card as B. Okay. Now, the third card can be C or third card can be D. Correct? I have fixed first two cards as A and B. So, the third card can be C or third card can be D. Okay. Now, similarly, let me fix the first card as A and second card as C. Okay. Here, what can be the third card? Can it be B? No. Because ACB means it is already covered here. ABC and ACB are same. Correct. With respect to the grouping, I have a group of ABC. So ACB is also a group of ABC only. So the third card cannot be B. The third card can be D. Has to be D rather. Okay. Fine. Now let me fix the first card as B and second card as C. Now what is the option left for the last card? It can it be A? No, it cannot be A. Correct? It cannot be A. The third card can be D only. Why it cannot be A? Because BCA is already covered in the grouping ABC. Correct? Correct? Fine. So the third card has to be D only. Correct? So we got so many groupings that are possible. Similarly, what are the other groupings possible? These are the only 4 groupings possible. No other grouping is possible. Correct? So totally 4 groupings are possible. Correct? Now let us use the meaning of combination and see, because grouping is referring to the combinations, right? How many combinations are possible? So what is NCR means? From a set of n elements, how many groups of R elements are possible? So here we are having a set of 4 cards. How many groups of 3 elements are possible? That is what is the question. So what is NCR? NCR is nothing but n into n minus 1, so on. I have to write R terms. So I will write till n minus R plus 1 divided by R factorial. Correct? That means I have to write 3 terms totally. R terms I have to write means here I have to write 3 terms. Means 4 into 3 into 2. That is 4 minus 3 plus 1. 4 minus 3 will be 1. 1 plus 1 is 2. So starting from 4 I am writing till 2 divided by R factorial is 1 into 2 into 3. This gets cancelled off. We get 4. So this is what is NCR telling. What we found out by actually writing the groupings here, NCR will directly give me. And also observe that NCR is same as NCn minus R. So 4C3 is same as 4C1. Why it is so? Because see, for example, if you are calculating 4C3, what is happening? 4 into 3 into 2 divided by 1 into 2 into 3. These gets cancelled off. Like this, the common elements will get cancelled off. So it eventually turns out that NCR is same as NC n minus R. Clear? What do you mean by orderings now? Now the meaning changes here. Okay. Let us write the orderings here. Now the first card I fix as A. The second card I fix as B. The third card can be C, or third card can be D. Correct. Now the first card I fix as A. Second card I fix as C. Now the third card can be what? B also, D also. Why? Because in terms of ordering, ABC and ACB are not same. Because the order is different. They belong to the same group. Please note, ABC and ACB belong to same grouping. That is, it's a group of ABC. Correct. But the ordering is different. So when we are talking about ordering, ABC and ACB are not same. So like that, if we write, what can we write? Suppose we have written 4 possibilities here, right? Okay, now let us write down the other possibilities. Now I fix the first card as B, second card as A. The third card can be C, third card can be D. Now I fix the first card as B. Second card can be what? First card can be B, second card can be A, and third card can be C or D. Similarly, first card is B, second card is C, the third card can be A or D. Like that I can keep on writing it. One thing you should observe here, we will go by the principle of counting now. We will go by the principle of counting. Correct? What principle of counting states is as follows. Now I have 4 cards. Now I need to find how many orderings of 3 cards are possible. That's what is the question. Correct? Now for the first card, I have the liberty to choose among any of the 4 cards. This can be any of the 4 cards. Correct? This can be A or B or C or D. So this has the liberty 4. Any of the 4 cards can come here. But moment the first card is A, please observe here, the first card is A, second card cannot be A. Second card can be B or C, or even you can have a second card as D. A, D can be the second card. A, D can be, third card can be either B or C. Correct? Yes or no? Correct? So that gives you the liberty of choosing what is the third card. So we observe that if first card is A, second card can be B, C or D. Correct? So I have fixed out of the 4 cards, I have allocated one among the 4 cards to be the first card. Now how many liberties I have to choose the second card? I have 3 liberties to choose the second card. Now observe here, I fix the first card to be A, second card to be B, for example say. Now how much liberty I have to choose among this third card? Given that I have 4 cards, it can be either C or it can be D. So I have 2 liberties to choose the third card. So it will be 2. So totally 24 groupings are 24 orderings are possible. That is what is your 4p3 saying. What is 4p3? I have to write n into n minus 1 into n minus 2 like that. NPR, that NPR is nothing but n into n minus 1 into n minus 2, so on till n minus r plus 1. So 4p3 I have to write totally how many terms I will be writing? R terms I will be writing. So 4p3 will be what? 4, I have to write 3 terms. 4 into 3 into 2, this is nothing but 24 terms. So that is what is your NPR. So please understand the concept of basic principle of counting. First, see, when you have, say, instead of 4 cards, for example, if you have 5 cards, for the first card you will have 5 any one among the 5 cards to choose. Second card can be any one among 4. Third card can be any one among 3. So if you have to choose 3 cards among 5 cards, how many orderings are possible? Means 5 into 4 into 3, that will be totally 60 orderings possible. Clear? Is this clear? Fine. Okay. So this is a problem now we are going to solve. A committee of 7 members has to be formed from a group of 8 lawyers and 8 policemen. What is the probability that part A, the committee has 4 policemen, the committee has 6 policemen, that is part B, and part C is committee has at least 1 policeman. Now first let us solve part A. This is very, very important to understand what part A means. Committee has 4 policemen. Okay, how many committee has, what is the size of the committee? 7 members. From 7 members, if there has to be exactly 4 policemen, has 4 policemen means what? It is exactly 4 policemen, that's what it means. Okay, now let me write in green so that the solution part is different from the problem part. Committee has 4 policemen. Total committee members possible is 7 members. Okay. Now, if you see, the question is, okay, let me say that there are 7 policemen. P1, P2, P3, P4, P5, P6, P7. There are 7 lawyers. L1, L2, L3, L4, L5, L6, L7. Now, the question asked is, from this group of 7 and 7, I'm sorry, 8 lawyers and 8 policemen, right? P8 will also be there, L8 will also be there. So from the group of 8 and 8, that is totally there are 16 people. Totally there are 16 people. From out of the 16 people, I have to form a committee which contains 4 policemen. Now, you see the 4 policemen can be P1, P2, P3, P4, or it can be P2, P3, P4, P5, or it can be P1, P5, P6, P8. So many possibilities are there. That is what, in short, what you are asked, from the set of 8, how many sets of 4 are possible? That is what you have to find. Because what? Probability of E is nothing but n of E divided by n of S. So what is n of S? What will be n of S here? How many group of 7 can be formed from the given 16 people. That will be this will have the all possible combinations of the committee members that could be formed. 1 lawyer, 7 policemen, 6 policemen, 2 lawyers, 5 policemen, 3 lawyer, 4 policemen, like that. 7 members can be formed in many number of ways. Again, the 3 lawyer can be any one among these. So n of S will be how many groups of 7 can be formed from the given group of 16. That is what is your n of S. And what will be n of E? What will be your n of E? How many groups containing 4 policemen can be formed. Correct? The moment you say 4 policemen, the number of lawyers gets fixed to 3 automatically. Because why they get fixed to 3? Because totally there can be only 7 members. Correct? So your n of s is nothing but 16. From a group of 16, how many groups of 7 can be formed? And n of e will be what? N of e will be always, you should have 4 policemen and 3 lawyers. Please remember, whenever in probability and comes, it always converts into a product. Or comes, it converts into a addition. Please remember this. Or comes, it converts into addition, and comes, it will convert into a multiplication. So you want a committee having 4 policemen. That means the remaining 3 will be lawyers. So you want how many committees such that 4 policemen and 3 lawyers can be formed. Clear? So n of e will be, how many groups of 4 can be formed from a group of 8 policemen? It will be 8C4 into, because there is a and, you need 3 lawyers, and this 3 can be any, how many groups of 3 lawyers are possible from a group of 8? So this will give you 3 lawyers. This will give you 4 policemen. Correct? So your probability of E will be how much? N of E divided by N of S, that is nothing but 8C4 into 8C3 divided by 16C7. This will be how much? 8C4. What will be 8C4? Yeah, calculate it. 8C4 will be 70 into 8C3 will be 56 divided by 16C7. 16C7. This will be 11440. So the answer will be 70 into 56 divided by this. This will be roughly 0.343. This is the probability that the committee will have exactly 4 policemen. Clear? Fine. Now we are coming back to the part B. We have solved part A. We are coming to part B. Now we have to pay each and every attention to the each and every word given in the problem. We have to pay attention to each and every word given in the problem. That is very important. What is told here? At least 6 policemen. Okay. Now committee has to be containing 7 members. Okay. Now you have a choice of 8 policemen and 8 lawyers. Correct? How many combinations? How can you form this committee? You can pick any one among the policemen. There can be, all the 7 can be policemen itself, and you can have 0 lawyers. You can have 6 policemen and 1 lawyer. You can have 5 policemen and 2 lawyer. You can have 4 policemen, 3 lawyer. You can have 3 policemen, 4 lawyers. You can have 2 policemen and 1 lawyer. You can have 1 policeman and 3 policemen, 4 lawyers, 2 policemen and 5 lawyers, 1 policeman, 6 lawyers, or 0 policemen and 7 lawyers. Okay. Now the question asked is at least 6 policemen. At least means what? It can have either 6 policemen, 1 lawyer, or 7 policemen, 0 lawyer. Correct? This is what at least means. So this is, both are favorable cases to us. So we have to evaluate both. N of S will still remain the same. N of S is still how many group of 7 is possible from given 16. This is still the same. So this will be 16C7. Whereas Your n of E is different. N of E will be different because E is different now. Because E is what? E is 6 policemen and 1 lawyer, or what? 7 policemen and 0 lawyer. Correct? Whenever or comes, it will convert to plus. Whenever and comes, it will convert to multiplication. Please remember. So what will be my n of E? N of E will be, I can, from a group of 8 policemen, I can have to select 6. So 8C6 into, from a group of 8 lawyers, I have to select 1 lawyer, 8C1, or from a group of 8 policemen, I need to select 7, and from a group of 8 lawyers, I have to select 0. Correct? This is what is n of E. Therefore, probability of E will become what? 8C6 into 8C1 plus 8C7 into 8C0 divided by 16C7. This will translate into what? 8C6 will be same as 8C2 into 8C1 is 8 itself. 8C7 is same as 8C1 because NCR is same as, remember, NCR is same as NCN minus R. Please remember this. This can help you to calculate it quickly. 8C7 will be same as 8C1. 8C1 is 8 itself. 8C0 is nothing but 1. Okay, remember this also, you can remember this. NC0 will be 1 always. Divided by 16C7. So what you will get? 8C2 into 8 plus 8 divided by 16C7. That will be 0.020. This is the probability. Clear? Now, we have to evaluate part C now. What is part C saying? At least 1 policeman. Now, 1 policeman means what? Here, let me change the color and go back to the... I have written all possible combinations here, right? So what will you get? You can have 7 policemen, 0 lawyers, 6 police. So this is a favorable case for part C. This is a favor. I need to have at least 1 policeman. So this is a favorable case for part C. This is a favorable case. Everywhere there is 1 policeman, right? But this is not a case because you have 0 policemen. So either you can write it as 7 policemen, 0 lawyer plus 6 and 7 policemen and 0 lawyer, or 6 policemen and 1 lawyer, or 5 policemen and 2 lawyer, or 4 policemen. Like this you can write it for every term. Or we are in, see, let me write it out in what I told. N of S still remains the same. N of S will be still 16C7. But N of E will change. N of E will be what? From a group of 8, I have to pick 7 policemen and I have to pick 0 lawyers, or I can pick 6 policemen, 2 lawyers, or I can pick 5 policemen, 3 lawyers. 5 policemen and this will be 1 lawyer, this will be 2 lawyers. Or I can pick 4 policemen, 3 lawyers, or I can pick 3 policemen and 4 lawyers, or I can pick how much? 2 policemen and 6 lawyers, or I can pick 1 policeman and 7 lawyers. This is what it will translate to ultimately. Now, instead of evaluating such a big expression, we can solve it in an intelligent way. What is that intelligent way? We know that probability of E is nothing but 1 minus probability of E complement. If I write it in for the given problem, if I write this, probability that committee will have at least 1 policeman is nothing but 1 minus probability that committee has no policeman. Correct? This can be formed easily. What is that? That is nothing but 1 minus probability that the committee has no policeman means what? N of E complement divided by N of S. This is nothing but 1 minus N of S is still the same 16C7 and N of E complement will be what? I need to get 0 policemen. How many cases are possible? Only one case is possible. Correct? So 0 policemen means what? 8C0. I need to have 0 policemen and I need to have 7 lawyers. This is what is the required thing. 8C7 is same as 8. 8C0 is 1. So this is nothing but 1 into 8 divided by 16C7 correct. That will be the total net answer will be 1 minus this, the net answer will be 0.999. So there is 99.999 chance that the committee will have at least one policeman. So I want you to understand what do you mean by at least and exactly. Part A we evaluated exactly 4 policemen, part B at least 6 policemen and part C at least 1 policeman. All the 3 are totally, the strategy we adopt to solve is totally different. Please pay attention and understand this. Okay. So this is another question. A bag contains 5 blue and 3 green balls. What is the probability that we get exactly 2 green balls when 3 balls are drawn in random? Okay. So how many balls are there? So what is sample space? First we need to find what do you mean by sample space. Sample space contains all possible outcomes. All possible outcomes for given experiment. Clear? For given experiment. So here what it will contain? Totally there are 5 blue and 3 green balls. So totally there are 8 balls. So sample space will contain all groups of 3 from 8. That is all groups of, so how many such groups are possible? How many groups of 3 are possible? N of S is what? Number of groups of 3 possible from set of 8. This is nothing but what? 8C3. That is 8C3 is your sample space. I am going to draw 3 balls are drawn randomly. So how many possibilities of 3 balls are possible? From a set containing 5 blue and 3 green balls, totally there are 8 balls. So 8C3 possibilities are there. Clear? Then what is your E? E is 2 green balls exactly. I want to get 2 green balls exactly. Okay. So 2 green balls exactly means how much? So that is you have to get 2 green balls and 1 blue ball. Correct? That's what you mean. When you draw 3 balls, you want to get exactly 2 green balls means what? 2 has to be green and 1 has to be blue ball. So how many green balls are there? There are 3 green balls available. Total how many 3 green balls are there? Green balls there are 3 and blue balls there are 5. Correct? So how many sets of 2 are possible from 3? This is nothing but 3C2 and means multiplication. 1 blue ball, that is from the given out of 5 you can get any one among them. So your probability of E will be N of E divided by N of S, that is nothing but 3C2 into 5C1 divided by 8C3. See, 3C2 is what? 3C2 is referring to the green ball. That is out of the 3 given green balls you can pick any 2. Similarly, the remaining one has to be a blue ball because you have been told that exactly how to get 2 green balls. Correct? So the remaining one has to be a blue ball. That 1 blue ball can be any one among the 5 available blue balls. And totally there are 8 balls. So 8C3 possibilities are there. So it will be 3C2 into 3C2 into 5C1 divided by 8C3. So there is 0.2678. This is the probability point, or roughly you can say 26.78% chance is there to get exactly 2 green balls. Now I am going to change the same problem in a different fashion and I am going to solve it, and we are going to understand lot of concepts out of this. So now this is another interesting question. Almost I have picked the same question here. A bag contains 5 blue and 3 green balls. What is the probability that we get exactly 2 green balls when 2 balls are drawn one by one? Part A is 1 by 1 with replacement. Part B is 1 by 1 without replacement. Part C is drawn 2 at a time. Okay. That is what happens. You have a bag. See, let me draw a figure. Okay. You have a bag containing 3 green and 5 blue balls. 5 blue balls. Okay. This is the bag. Now, part A says that you are going to draw one, see the color and put it back. That is what is 1 by 1 with replacement. Okay. Part B is, okay, let us first solve part A. This is what is part A saying. You draw one, see the color and put it back. That is what is with replacement. Okay. So let us solve part A here. With replacement. Okay. With replacement means what? Now what is your sample space? What is your number of sample space? This is very important to understand. So how many balls are there? There are totally 8 balls. There are totally 8 balls. Now every time I pick a ball, see the color, then I put it back. Okay. So the number of balls are always 8 for all the draws. First time also you get to pick 8 balls. Second time also you get to pick. During the first draw also you get to pick 8 balls. During the second draw also you get to pick 8 balls. Correct? So number of balls available for first trial is 8. Second trial is also 8. So totally there are 64 possibilities. Clear? And now what is your favorable case? What is your event? The event is 2 greens is what you want. That is, first time also you want a green, second time also you want a green. Correct? So out of the 8 greens available, out of the 3 greens available, first time you want 1, and out of the 3 greens available, second time also you want 1. So what you will get? 3C1 and 3C1. Correct? So probability of E will be what? Nothing but 3C1 into 3C1, because and will translate into multiplication, divided by 64. This is nothing but 9 by 64. Correct? Okay. Now let me solve part B here. Part B, let me draw the diagram again for understanding. You have a bag, you have 3 green and you have 5 blue. 5 blue balls. Now the thing is, you draw one ball, you draw a ball, see the color, but you are not going to replace it. So the count of balls available for subsequent draws will reduce. Correct? Because part B is without replacement. Part B is without replacement. Okay. So what is going to happen? What is your sample space here? First time you get to take 8 balls. Second time you get to pick one from the 7 balls only, because one ball you have drawn and you have not replaced. Correct? Fine. Now what will be the sample space? First time you get to pick anything among the 8 balls, whereas second time you get to pick only among 7 balls. So totally 56 possibilities will be there. Okay? Okay? Fine. Now, what is your event? You want to get green and green. That is first time also. This is what is your sample space. Your event is what? First time also you want a green. Second time also you want a green. Now for first chance, how many green balls are available for you to pick? 3 green balls are available. But for the second chance, you will have only 2 green balls available to pick, because assume that first time you have already got a green, second time number of green balls will reduce. Correct? So this is 6. So probability of E will be 6 by 56. What will be that? 6 divided by 56. And clearly 6 by 56 is less than is less than 9 by 64. That is what? Without replacement, probability reduces than with replacement. Please remember this. Okay? Fine. Okay. Now still we are left with part C, right? What is part C? 2 green balls exactly drawing 2 at a time. Correct? That is, you have a bag which contains 3 green balls and 5 blue balls. Now what is asked is, you directly put your hand and take 2 balls out of it. You pick 2 out of it. You can pick any 2. Okay. Okay, if the color I am drawing is blue is confusing, let me put, you can draw any 2. Color is not known. Now the question is, what is the probability that both of them are green? Clear? What is your sample space? So how many balls are available? 8 balls are available. 8 balls are available. So you have to pick 2 balls. Pick 2 balls. So what is the sample space? N of S is nothing but how many groups of 2 are possible from the given set of 8. So N of S is nothing but 8C2. And how do you consider it as win? You consider it win only. E is what? E is what? 2 green balls. That is, from the available 3, when you pick 2, both of them should be green and none of them should be blue. You don't want to pick anything from the blue. 3 of them should be green. Correct? So, what is probability of E? Probability of E is nothing but 3C2 into 5C0 divided by, this is 2 green and 0 blue. You don't pick anything out of this 5 and you pick both out of this 3, divided by 8C2. This is nothing but again 6 divided by 56. So the idea is to understand how are the different experiments conducted, that is one by one without replacement, one by one with replacement, drawing two balls at a time. All these things are having its own way of solving. Please understand and appreciate the differences between the way we have solved it. Okay, fine. We will be seeing more problems in the subsequent classes.